Here we're going to video kind of a little walkthrough of how to differentiate between mass and weight. So it's kind of from what we did from class today. So let's say we have a student with a weight of 150 pounds. 150 pounds is what we would call the English system of measurement. This is a weight in pounds. And what we're going to do is we're going to try to convert pounds into kilograms. So what I would need to do here is I know that 1 kilogram on Earth weighs 2.2 pounds. So I can actually take 150 pounds divided by 2.2 pounds per kilogram, or per 1 kilogram, and I can take and divide that, and I get an answer of 68, that's supposed to be 68, excuse me, no decimal there, 68 kilograms. So this student's mass is 68 kilograms. In other words, his mass is constant anywhere in the universe. Now this is an important one. Mass is staying constant. It's the weight that's going to change, right? Weight are based on g. And typically we say that g, right? Well, g is gravity. Gravity is really, we're talking about the acceleration due to gravity. So g is the same as a. So really this is kind of just this is essentially Newton's second law, but we're substituting in g for a. We're calling F of g weight. This F equals ma could be any force, but here we're specifically identifying F of g to be weight. So let's plug this in a couple locations. So let's find this individual's weight here in newtons on Earth. So I know that 68 kilograms, right? So I'm just plugging in here, mass times g on Earth is, right, we can imply that's a negative 10 meters per second squared, and you get 680 newtons. This student's weight is 680 newtons. Now that is in the metric system. That 680 newtons equals 150 pounds, that these are equal. It's the equivalent of making a statement, right? 680 newtons equals 150 pounds. It's the equivalent of saying that 12 inches equals 1 foot. Different units of measurement, as newtons is different than pounds. So let's convert this student. Let's say the student weighs 150 pounds, right? Same student from above, right here. And let's find out how much the student weighs on the moon. So let's say 150 pounds over the Earth, 10 meters per second squared, right? That's g on Earth. And let's solve this for x pounds. It's supposed to be lbs for pounds. And I know that on the moon, it's negative 1.6 meters per second squared. So I can cross multiply. So 150 pounds times 1.6 divided by 10. This individual weighs 24 pounds on the moon. And there we just walked through how to solve. Going from knowing our weight on Earth, finding our mass on Earth, but it doesn't really matter. Mass is constant, so its mass is the same anywhere. We can then solve for our weight in newtons. Plug in mass. I know g on Earth is 10 meters per second squared, so mass times gravity is 680 newtons. This value of 680 newtons is the equivalent of 150 pounds, so I'm just comparing the English system to the metric system. These are really just bouncing back and forth from those. And then I found out, by knowing my weight in pounds on Earth, finding my x pounds on the moon. And I found out it's 24 pounds on the moon. So there you have it.